Mechanisms in motion are short revision videos which show you the effect of arrows in organic chemistry mechanisms. As the format is a quiz, you will be presented with multiple options for how the mechanisms will occur. Based on your choice, move ahead to the timestamp and you will see how your choice affects the reaction. If you are correct, you will move on to the next step in the mechanism. If you choose the incorrect or less likely answer, the reason for this will be explained and then you'll be given the correct answer. Saponification or ester hydrolysis is the process through which a base catalyzes the transformation of an ester into a carboxylic acid using a base and water. Due to the use of a strong base, this reaction is irreversible, meaning you can obtain complete conversion of starting material to the product. The first step in the reaction involves attack by a strong base like sodium hydroxide. The base can either attack the carbon of the carbonyl to form a tetrahedral intermediate, or it can deprotonate a hydrogen near an electronegative atom like oxygen. Deprotonation of the carbon next to the ester is not likely to happen. While next to an electronegative atom, this proton is not acidic enough to be removed in this situation. The carbonyl is more electrophilic and therefore will be attacked first. The attack of the base at the carbonyl causes the carbonyl double bond to break, forming a tetrahedral intermediate. This step occurs as the carbon of the double bond is delta positive and therefore is easily attacked by a nucleophile like the hydroxide ion. This step is the correct first step in the reaction. The next step in the reaction is reforming the carbonyl. When reforming the carbonyl, a bond to the carbonyl carbon needs to break to prevent the formation of a pentavalent carbon. Therefore, either the benzene or ethoxide group is removed from the molecule. The elimination of benzene will form a negative charge on the benzene ring. By adding a negative charge, the benzene ring will no longer obey the 4n+2 rule for aromaticity. Therefore, the compound is no longer aromatic. As this is highly unfavorable, this step does not occur. The elimination of ethoxide forms an ion with a negative charge on the oxygen. The negative charge can be stabilized in solution by coordination of the sodium ions. In reforming the double bond, the carboxylic acid is formed. This is the correct step. Even though the ethoxide can be stabilized by sodium ions in solution, it is still able to react with other molecules in solution. Therefore, the next step in the reaction is to either have the reaction of the ethoxide with the carbonyl in a nucleophilic attack, or the deprotonation of the carboxylic acid formed in the previous step. While nucleophilic attack at the carbonyl could occur, this would take you back to the same tetrahedral intermediate formed in the previous step. This tetrahedral intermediate would then reform the carbonyl bond by kicking out the ethoxide group for the same reasons given in the previous step. The deprotonation of carboxylic acid results in the formation of ethanol in the carboxylate ion. This step is the correct step as the proton of the carboxylic acid is very acidic and therefore can be removed easily in the presence of a base like ethoxide. The final step of this reaction is the reprotonation of the carboxylate ion by adding acid to the solution. The acid will neutralize any leftover base in solution and protonate the carboxylate ion, forming the final product, the carboxylic acid. This is the overall reaction scheme for saponification. The first step is a nucleophilic attack by the hydroxide ion forming a tetrahedral intermediate. This is then followed by ethoxide elimination, which then deprotonates the carboxylic acid formed in the previous step. Finally, if acid is added to solution, the carboxylate ion will be reprotonated, forming the carboxylic acid product. This slide shows the overall mechanism of this reaction drawn as you would in an exam with curly arrows. Thanks for watching the video. If you found it helpful, please leave us a like or a comment, and subscribe if you'd like to see future videos of mechanisms in motion.